CCl, CH, Cl, Cl, and HCl. Okay, so for, let's do CH first. For the CH bond, that one was 413 for its bond enthalpy. For the Cl-Cl bond, these are the ones we broke, that one was 242, and these are kilojoules per mole. And then for my carbon-chlorine bond, that's one I formed. These are the ones I've broken. So the ones I formed, so carbon-chlorine bond, that bond enthalpy, if I look at that table, is 328 kilojoules per mole. And then the very last one was the HCl bond, and I had one of those. And then the HCl bond was 431 kilojoules per mole. Okay, so I have all of my bond enthalpies. My goal is I want to take the sum of the bond enthalpies that I broke, some of the bonds that are broken, so these two. So if I do then my 413 plus my 242, and then I want to take the sum of the bonds that I formed, so I want to do 328 plus 431. So for the bonds that I broke, should get 655 kilojoules per mole. So this is what I broke. And then if I did the 328 plus my 431, that should give me 759 kilojoules per mole. Okay, and then to find that overall change in enthalpy, we said that it was the sum of what I broke minus the sum of what I formed. So I'm going to do my delta H is equal to 655 kilojoules per mole minus 759 kilojoules per mole. And then if I do that, that's going to tell me what my overall enthalpy of reaction is. So did I release energy? Did I need to absorb energy to make this reaction happen? So I should get a negative 104 kilojoules per mole. So what I found was that ultimately when carbon and hydrogen bond broke and the chlorine bond broke to form these, I released energy. So this would be considered what we call an exothermic reaction because we're releasing energy. But this is how I'm going to do a bond enthalpy problem. Okay, so we should get a negative 104 kilojoules in terms of its energy. We can also measure an average bond length for different bond types. So we already said before that as we gain multiple bonds, our bond length should get shorter. So as the number of bonds between two atoms increases, the bond length will decrease. So this is just another way for me to see that I have more atomic overlap, which means that the bond length should decrease because of this more overlap, more attraction, stronger bond. So bond enthalpy should be higher as bond length gets smaller. Should make sense. Okay, let's do another one of these. So I want to just do this top one first. Okay, let's just do this top one. So I have my organic molecule here with oxygen making my carbon dioxide, and then I have water, and then it's already balanced for you. So let's actually redraw this one out and then talk about what we're breaking, what we're forming, and then how am I going to find the overall delta H of the reaction, okay? So when I do this, first thing I want to do, sometimes it just helps to draw a picture and then to write, this is how many I'm breaking, this is how many I'm forming. I think you should always do that. So if I redraw that picture on here, we had carbon, carbon, and then that was attached to all hydrogens, but I have two of those, right? So let's just go ahead and break apart this one. So I have 6 carbon-hydrogen bonds in just one of these molecules, but I really have it times 2, so I'm about to break 12 carbon-hydrogen bonds. Okay? So right now I just want to talk about what I'm breaking. So I've accounted for all of the carbon-hydrogen bonds, but I also have this carbon-carbon bond. And since I have 2 of these molecules, I'm breaking 2 carbon-carbon single bonds. Okay, but now I'm also reacting that with 7 oxygen molecules. So I'm about to break 7 O double bond O bonds. So now I have 7 times my double bonded oxygens. So these are all the ones I'm breaking. Let's go on to the forming side. So what do we form in this? We formed 4 carbon dioxide molecules. So ultimately, when you're seeing this, you should be thinking of a combustion reaction. And you know logically that a combustion reaction will release heat. At least it should. It's a combustion reaction. So if it's not a negative number that we end up getting here, something must be wrong, okay? So that should be in the back of our minds thinking about this logically too. So I have 4 carbon dioxide molecules. So I'm forming a carbon-oxygen bond. But how many am I forming? Well, I actually form 2 for every 1 carbon dioxide molecule, but then times 4, so I'm really forming 8 carbon-oxygen double bonds. And then I produce carbon dioxide, but I also produce water, so HOH here. And then that one I have 6 of those. So since I form an oxygen-hydrogen bond, but I form 2 of them for every water molecule, it's really like I'm forming 12. So then I have 12 times whatever the oxygen-hydrogen bond enthalpy is. So this is what I'm breaking, this is what I'm forming. Let's go back and do that equation, where to find the overall change in enthalpy, that's going to be equal to the sum of what I break minus the sum of what I form. And now I need to look at my table to find out what these numbers are. So the CH bond was 413. So I'm going to do 12 times 413 plus 2 times the carbon-carbon single bond was 348. So 2 times 348 plus 7 times the oxygen double bond is not 799, it is 495. So I want to add all of those up, and then I'm going to subtract it from what we formed. So what we formed was 8 carbon-oxygen double bonded, and that's at 799. So 8 times 799 plus 12 times my oxygen-hydrogen bond, which was 463. So if I add all of these up and subtract it from the sum of that, our overall should be, overall enthalpy should be a negative 2831 kilojoules per mole. Okay, so you should get that after you type all of this in. But this is just to kind of do another example of what that would look like. So you have another one that's here on your PowerPoint. So if you can, I would like you to try this one, and we can talk about this one on Friday. But I also have a paper that I've uploaded along with this video. It has 2 practice problems that go along with this. If you want to try to do those, and we'll cover those on Friday as well. So we'll do our Vesper Yoga, then we'll do the bond enthalpies. If you have any questions about these, post on your blog, come by tomorrow, or just hold them off until Friday, whatever you want. And then we'll continue on probably doing a little bit more practice with this, and then also doing our Vesper Yoga, and we'll start off with molecular geometry too. Don't forget, I'm going to give you a small Lewis quiz at the beginning of class on Friday, and I'm also going to post some extra practice stuff with Lewis structures, so if you want them, they're there, and I'll post an answer key to those tomorrow, so you'll have them, and then I can just go ahead and schedule that to upload with the answer key if you want to see that as well. All right, have a really wonderful day. I will miss you guys tomorrow, and I will see you, though, on Friday for our fantastic yoga session. Bye!